Hi everyone, today we're going to be talking about the 2018 AP Chemistry FRQ number 2. This FRQ mainly deals with acid-base titrations and equilibrium. For this first question, we are given a balanced chemical equation for the formation of nitrogen dioxide. They give us 4 molecules of NO2 and 4 molecules of NO and ask us to draw out the particles of the reactants. We see that we can only have NO and O2 as a reactant, so we first put all of our excess nitrogen monoxide from the product side back on the reactants. Then, we see that we made up 4 NO2 molecules, and by working backwards with the molar coefficients, this means that we used up 4 NO molecules and 2 O2 molecules, so we add those to the mix and we're done. Using Gibbs free energy, we can calculate the constant K by reworking the equation G equals negative RT ln K to solve for K, and we get that K equals e to the power of negative G over RT. By plugging in all of our constants and our G from the table, we get that our K is equal to 0.70. Here, we have to think about our equilibrium constant. K is less than 1, so there will actually be more reactants than there are products at equilibrium, so it makes sense that all of the reactants wouldn't get converted to product, which would be the case if N2O3's partial pressure was 1.0 atm. The enthalpy we are given states that the reaction is exothermic, so increasing the temperature would shift the reaction to the reactant side according to Le Chatelier's. For this reason, we have to disagree with the student. Let's look at this compound based on its elements. First of all, hydrogen is not going to have any lone pairs when it's bonded, so we can ignore that. Hydrogen also likes to form one bond, so let's connect it to the oxygen molecule. Oxygen has more than one bond it would like to form, so we can connect one more bond to the nitrogen molecule. Now that oxygen has accumulated 4 electrons through bonds, we have to draw the 2 lone pairs, and we can draw one on top and one on bottom. Next, nitrogen has 1 bond, but it wants 3. The last oxygen also wants 2, so we can place a double bond on the nitrogen-oxygen bonding site at the end of the molecule. We finish by placing 2 valence electrons on nitrogen and 4 more on oxygen. We see that nitrogen has 2 bonding sites on either side that have bonds, and 1 more bonding site with the 1 lone pair, so its hybridization is sp2. Here, we have to use the titration curve. We see that our HNO2 has been neutralized when 20 milliliters of KOH has been added, so we take that, find our moles of potassium hydroxide, which is 0.0020. We then use stoichiometry, and since there is a 1-to-1 ratio of hydroxide to our acid, we know that we have 0.0020 moles of HNO2 acid. The original sample is 0.100 liters, so by dividing by that, our molarity would be 0.020 molar. We know that at the midpoint of a titration, pKa is equal to pH, so we go to around the midpoint of the titration, and we see that our pH is 3.4, and so we can answer that as our pKa. Finally, we have to consider the species in this reaction. 15 milliliters of potassium hydroxide added is past the midpoint of the titration, so there is more conjugate base than there is acid. Therefore, there is more NO2-, and that's all you need to say, with that justification, of course. That's all I have for y'all today. I hope this video helped you, and I'll see you guys in the next one.